Let's talk about NAT servers next. The core idea adopted by NAT is internal private network, external public network. We just said a kind of NAT called static NAT. The public network and the private network are actually two-way. But when we go to use dynamic NAT and PAT, actually, our traffic is only from intranet to extranet. Then the external network replies with the packet. Because when we go out online, a mapping table will be formed on this device. After the data goes out, when this traffic comes back in the future, it has to look up the meter. If there is this mapping entry in the table, it can be converted back towards. If there is no traffic, there is no return. It means, if you use this way, you are directly on the public network. Use 100.1.1.1 to access the private network. You cannot access this device, because it is a private address, even if you can find a device like it. But since this data just didn't access you internally, it does not have this mapping in its mapping table. Even if your data arrives on this device, since it cannot find a corresponding mapping, it cannot reply to the server. But sometimes, when you are working on a project, often found, now a client, originally, an internal server was an intranet server. But now maybe the company has grown in size. Hopefully this internal server also provides some access to the outside world. So what should I do? There is no direct access to a server on the public network, because the server itself is an accessed end. It does not actively generate traffic. It will not access other devices on the public network. It is only accessed. We can do a mapping here. For example, I configure the NAT server on this device. If it accesses a certain port on this device in the future, it can jump to a certain port of the internal server, and then let it access, which is equivalent to NAT server can realize this requirement. But all you need to configure is, you put the service on a certain port of the internal server, a service converted to this address on the public network, and then publish it externally. Then others will be able to visit in the future. Because we can reach a public network address on the public network, you can access the corresponding service on this public network address. As a company device, it can be configured. If other devices access its services, it can transfer the traffic to the downlink server. Then you can access it accordingly. To be honest, still want to access the public network. This needs to be configured accordingly on this router. Some friends may find this too troublesome. You have to configure one by one. Yes, because your company will not have so many servers waiting to be accessed by others. Usually, if we have one device, we just need to configure one. The specific scene is different. Like the daily employees in the company. There are many people who use the internet. There are only a few configurations for the server. That's it for a small company. Let's talk about its configuration. We still focus on configuration. It is a configuration. After watching, let's explain. Very simple. This is the reason why I want to simulate a router on the PC. I want to wait to mock a service. Simulate a telnet service on the PC. I want to enable telnet on the PC. There is a command that is the line. Then set up a virtual terminal link. VTY. Set user 0 to 4. This is when we talked about configuration before. Earliest configuration. Password Cisco. Transport input telnet. I am now on. PC1 is allowed to be telnet. Telnet is port 23. I hope now the traffic on the public network can be transmitted from this device in the future to access the telnet service in OC1. As just said, I should configure it on the gateway device. Let's look directly at the command. IP NAT inside source. It is a static. We want to enter one by one. Then enter the question mark. We are now accessing the telnet service. Then it is based on port 23 of the TCP protocol. The TCP protocol at the transport layer is used. I now want to internal this 192.168.1.10. It's port 23. That is the telnet service. Future mapping is 100.1.1.1. A port 23 of the public network outbound interface. Let me explain this sentence. If it is set internally now, later, then you will find. Now if it accesses port 23 of 100.1.1.1 on this public network, that is, it telnet this interface address. Then the gateway will be mapped to port 23 of the internal 192.168.1.10. The gateway will forward the traffic down. Let it access port 23 of the PC connected to the gateway. That is, it telnet is this device. But it can log on to PC1. We'll wait for a verification. Because if in this telnet 100.1.1.1, then enter the gateway, it proves that the login failed now. If log on to PC, it proves that our mapping is successful. We can do experiments to verify. But I tell you, we usually don't enter 23 here. Because we usually do not configure the internal and external ports to be consistent. For example, now it telnet this address. And found. Telnet this address is really telnet to a device inside it. It's not very safe. It found that port 23 is open. It can telnet. It actually logged on to a server inside the company. It's relatively dangerous. We generally don't do source port mapping. We usually make a modification outside. For example, mapped to external 10,000 ports. We press enter. Now that we have configured, let's look at a more important thing first. It is the NAT table. You will find, now that I have finished typing, there will be such a mapping in the NAT table. The internal 1.10 port 23 is mapped to the 10,000 port of 100.1.1.1 on the public network. Is now a static mapping. Only static. You can directly see it in the mapping table after inputting. If dynamic, you have to have traffic access to see. Then let's come to the operator to test it now. We are going to telnet. Telnet 100.1.1.1. I won't press enter now. Because it won't hold down. Because telnet is not accessing 100.1.1.1 now. Instead, the 10,000 must be added later. Actually, I am accessing this port. Then came in. I telnet from the operator here is the 10,000 port of 100.1.1.1. I'm here on PC1. So saying this mapping means something like this. Publication. Now a server inside. You only need to access this interface. Access port 10,000 of this address. Then it can log into the internal server. Externally, the company's internal server is this address. But actually it's not. So it is equivalent to. It can protect the private address of the internal whole. Secondly, as a private address, corresponding access to traffic on the external public network. This is also what NAT can do. And NAT is at the beginning of the overall design. It's not for online use. NAT was originally a security method. I give a simple example. For example, this is an intranet. This is also an intranet. They will have some business dealings in the future. When you have business dealings, you must communicate. There may be some traffic exposure problems in communication. For example, the address may be leaked. We don't want other people's addresses to appear in their respective internet segments. I also don't want my address to be exposed. Usually say, we scrub the address. It is to convert NAT between both sides of the export. Then make a fake address. Communicate with each other. This also works. Does not affect business traffic. But no one can get the specific device and address of both parties. Okay. The above part is NAT. Finally, before we talk about the experiment, let me first give a brief introduction to this SDN. To be honest, we must not understand this thing when we learn it in the NA stage. But the outline has. We have to talk about it. Actually, a lot of knowledge in the courseware is too difficult for now. I will pick some that I think everyone can accept at this stage. Before I talk, I will open the experimental environment. Otherwise, the device will start too slowly. This is a small exercise at the end of the class. It's not that difficult. We are just doing a more comprehensive exercise. SDN is called Software Defined Network. What we have learned before is actually decades old technology. E.g. OSPF, VLAN, EIGRP etc. As old technology. Many devices support these technologies. Manufacturers can't keep pushing the old and bringing forth the new. Otherwise, there will be no money. So actually for SDN, it is both a new type of solution. It is another trendy learning direction, so to speak. Because the entire internet actually follows the manufacturers. Let me briefly introduce the usefulness of SDN. It can solve some common problems in our daily network.